All right, hello everyone. This is Miss K. Sorry I'm not here today, but we're going to do a quick video on how to do a dihybrid cross. Monday was a little rough because the internet wasn't here, and those of you who are here on Tuesday and had okay internet because I was at my house and you were at your houses with hopefully okay internet, this will be a little bit extra practice for you. All right, so we're going to go over this example that I have on my whiteboard right now, and then we're going to go over today's activity, and then you guys can just spend the rest of the class doing that activity. All right, so on the whiteboard, I have a prompt for you. All right, on another planet is a species similar to humans, and with this species, having 3 arms is dominant over 2 arms, and having hairy arms is dominant over not hairy arms. So what I like to do in this scenario is kind of just come up with the genotypes, right? So I'm going to write this in blue, and I'm going to say 3 arms can be a capital T equals 3 arms, and a lowercase t can equal 2 arms. Okay, and then as far as hairy versus not hairy, I'm going to say a capital H is for hairy arms, and a lowercase h is for not hairy arms. So this is just to keep me thinking straight. Okay, so it's written down so I don't confuse myself later. Highly recommend you guys do this. All right, so now that we know that based on that prompt, there's another prompt that says a male who is heterozygous for 3 arms and not hairy arms mates with a female that is homozygous for 2 arms and heterozygous for hairy arms. What will the phenotypic ratios of the offspring be? So we're going to have to do a dihybrid cross here and make a big ol' Punnett square, probably. We'll see. All right, so the steps below are the steps that I like to do to fill out these big giant dihybrid cross problems. All right, the first one would be to identify the cross. If it's not blatantly just told you that it's, you know, capital G, lower G, capital H times lower G, lower H. Okay, if they just give you that, cool. You don't need to spend time doing that step. But identify the cross is super important in word problems like this. All right, so we'll do things like underlining important things to figure out what the cross is. All right, so let's start off with the male. A male who is heterozygous, I want to change that color, sorry. A male who is heterozygous for 3 arms. Hetero, think about what that means. Hetero means different, right? So if it's heterozygous for 3 arms, they likely have a capital T and a lowercase t. That capital T is the one bully that's needed for him to show that trait of 3 arms. All right. Then he is also a not hairy armed individual. The only way for this man species thing to not have hairy arms is if he doesn't have any dominance in that genotype. Okay, so he would end up being, and I'll type this out, the male would end up being a capital T, lowercase t, because he is heterozygous, meaning different, for 3 arms. And then he will end up being a lowercase h, because he does not have hairy arms. If he did, he would at least have 1 capital H. All right. Now let's figure out what his mate is. Okay. His mate has, she is homozygous for 2 arms. Homo meaning same. All right. But she's also got 2 arms. She's got that recessive trait. So if she's going to have a homozygous genotype, either capital A, or lowercase a, okay, the same. All right, if she is homozygous for 2 arms, the recessive trait, that means she's going to be lowercase t. All right, then it says she has hairy arms, and that she's heterozygous for hairy arms. So she will have that different genotype, one capital, one lowercase. All right, so she will have a capital H, lowercase h. So hopefully we can all agree that this is the cross. Hopefully, right? Okay, let's go. All right, so step 2 then is to figure out the gametes. All right, so I like to do the FOIL method. So I'll type that out, FOIL, first, outer, inner, last. That's FOIL. Okay, so we're gonna do that. We're gonna write out the male's genotype, the capital T, lowercase h, lowercase h, and we're going to FOIL that. All right, so I'm going to write that out. Capital T, I'm going to space it out just a little bit so you could see my lines a little bit better. All right, so this is the male genotype. All right, so we are going to do the first, outer, inner, and last. All right, so follow along with what I'm drawing on the screen. So what this means is the first of the first trait and the first of the second trait. So the first T and the first H. Okay, the first T and the first H. Okay, so the first gametes for that is going to be capital T, capital H. Then we're going to do outer. Okay, so the outermost T and the outermost H. So outermost T and the outermost H. Then inner. Sorry, it's taking me a second to click all these colors and stuff. All right, let's do blue. So the inner would be the innermost T with the innermost H. So these guys right here. So that would be a lowercase t, lowercase h. And then last would be the last t with the last h. Let me get, I don't know, purple. So the last t with the last h. So that would be a lowercase t, lowercase h. Okay, so that is all the gametes for the fathers, right? Now let's do that again, but for the mother. All right, so I'm going to spread her out to lowercase t, uppercase h, lowercase h. We're going to FOIL again. All right, so we are going to do first of each set. So lowercase t with a capital H. Let me lower that a little bit so I've got more room. All right, outer. What color did I do? Green. So outermost T with the outermost H. Then we're going to do inner, which I did blue. So innermost T with the innermost H right there. And then last, which I did purple. All right, last T with the last H. So hopefully this makes sense so far. All right, now we have our gametes for the father and for the mother. This is where we would cheat now, if the cheat's available to us. All right, so we're gonna look at the individual level. Okay, so we have this individual right here. And with this individual, we will cross off any copies of gametes within that individual. Not even looking at the mother, cannot look at the mother. All right, so what can we cross off? Okay, so we have a capital T, lowercase h. And oh, we have another capital T, lowercase h. Cross that off, don't care about it. All right, then we have a lowercase t, lowercase h, and then another lowercase t and a lowercase h. Get rid of it, who cares? I don't care. Let's get rid of it. Let's simplify this square that we're going to have to do from a 16 box Punnett square to hopefully a smaller box. All right. Now we're going to look at this other individual, the mother. Okay. And we're going to cross off again anything that is a copy. Lowercase t, capital H, not seeing it again. Okay. Then we have a lowercase t, lowercase h, and then two more of those. Get rid of them. So we went from a 16 box Punnett square to now a 4 box Punnett square. That's so much better. All right, so why don't we start setting that up? I'm gonna put the mother on the top just because, you know. So I'm gonna put TH, sorry, let's do normal colors. T, lowercase t, capital H, lowercase t, lowercase h. Then I'm going to put the father on the side, capital T, lowercase h, and a lowercase t, lowercase h. Then I'm going to draw my super horrible box because I don't care. Oh, wait, can I make it nice? All right, I can make it nice, but I want to make it blue just because who cares? All right, so we've got our box here. I'm going to add some lines to it. Look at that beautiful Punnett square. Cool, whatever. All right, so then we're going to drop the top gametes down and bring the side gametes over. All right, so this one's going to end up being capital T, lower t, capital H, lower h. Remember, we're going to keep those genes, that specific genes together. So the T's are going to stay together, the H's are going to stay together. And when we're writing these out, the capitals come first. All right, so the capital T comes before the lowercase, the capital H comes before the lowercase. All right, so I'm going to fill this in quickly. Capital T, lowercase h, lowercase h. This one would be lowercase t, capital H, lowercase h. And then this one would end up being lowercase t, lowercase h, lowercase h. All right, so there's that. Okay, so that would be steps 3 and 4, assign the gametes, fill in the table. Then step 5 is identify the phenotypes. All right, so we're going to figure out what phenotypes are going to show in each of these possible individuals. All right, so looking at this box here, there is a capital T. I want a different color. There's a capital T and a capital H. So remember, if it is dominant, if it is capitalized, it's the bully. You only need one bully per trait. All right, so this individual is going to be a capital T, capital H. This individual will be a capital T, lowercase h. In this lowercase h situation, lowercase, there is no bully, so that recessive trait will show. This one will end up being lowercase t, capital H. And this one will end up being lowercase t, lowercase h. All right, so we've identified the phenotypes. So this top left is going to have 3 arms and hairy arms. The top right is going to have 3 arms, but not hairy arms. The bottom left is going to have 2 arms that are hairy. The bottom right is going to have 2 arms that are not hairy. All right, so now we're going to count the phenotypes. All right, so what do we mean by that? So kind of like just what I talked about. We're going to talk about the 3 arms and hairy, also known as dominant. We're going to talk about 3 arms and not hairy, also known as dominant recessive. We're going to talk about 2 arms and hairy, which would be recessive dominant. And then we're going to talk about 2 arms and not hairy, which would be recessive. Now we're going to go and count all those up to find the phenotypic ratio, just like this question is asking. All right, so now we're going to see how many of these have a dominant trait. Now this is where we look at this information here. All right, so dominant trait. Here is a dominant. This one's not, this one's not, this one's not. So we're going to say that there is a 1 right here. Now we're going to figure out how many have a dominant and a recessive trait. This one's dominant, this one's recessive. This one's not, this one's not. So there is a 1 here as well. Then 2 arms that are hairy. So a recessive with a dominant. We see that in this individual and no other individuals. So this will be a 1. And then a not harried arm, 2-armed individual, the double recessive, we see that here. 1. So in this situation, we would have a 1 to 1 to 1 to 1 ratio. Okay, we would have 1 of every kind. And if we did not take this shortcut and we instead did the entire 16 square Punnett square, we would find a 4 to 4 to 4 to 4 ratio. Same thing, if you simplified that 4 to 4 to 4 to 4, it would go down to 1 to 1 to 1 to 1. Same thing if you ended up with a 3 to 1 ratio on your cheated, shortcutted Punnett square. If you did the entire 16 box Punnett square, it would be a 12 to 4. Reduce that 12 to 4 down, it would be the same thing as that 3 to 1 that you got. All right. So I just wanted to walk through this with you guys. And now I would like you guys to spend about 5 or 10 minutes looking at the key that I posted on Google Classroom. Compare that to your work, all right, from last night's homework. So that way you could see the steps. I've made little comments on sticking points, things like that, and that key. So that way you could have extra practice and extra understanding in how these dihybrid crosses work. All right. And then we're going to have a quiz on Monday, Tuesday, or whatever days we have school next week, because I know school next week is really funny and weird. But the next time you have class, you will have a quiz on the material from monohybrid crosses, Mendel's laws, and dihybrid crosses. All right. And if you have any questions on anything, shoot me an email. I will likely be available this weekend if you're super desperate and you want to hit me up on Zoom so we could talk in person and draw things out. I'm available for you. All right. Okay. There's that. All right. But now I'm going to walk you through how to do your assignment really quick. So like I said, after this video is done, you'll have like 5 or 10 minutes to look at your homework and the key and understand what you did correctly, understand what mistakes you made. And then once you are done looking at that key and reviewing it with your homework, you are going to do the Dragon Lab activity. All right, so what is this Dragon Lab activity?